In this video, we will fix all the issues of the read-only type. So let's get started. So let's see how we can fix the read-only type. So let's say we have this person type here, and we have a name here, which is a string, and we have an address, which is an object containing a street, which is also a string, and the street number, which is also a string. Now, when we have a person object like this, and we say this is of type person, now we say we have our name of Christian and our address like this with the street, which is street, and number, which is 1 like this. Now, we of course can change this when we set the name to anything, for example. Now, we could of course use the read-only type like this. We can wrap this with read-only, and now we cannot change the name or the address. Now, the problem with this approach is that when we do something like this, we say address.street, we can see that this still works because read-only does not deeply make our properties read-only, but only the most upper properties. So this is the first thing we want to fix. So what we want to do is we want to have a deep read-only, which also makes all our nested properties read-only. Now, the second thing is something I want to show you in regards to setters, for example, or to functions which change certain elements. Now, let's say we have an array here, and this is a string array. And what we now, of course, can do is we can use push or pop on it. Now, what happens when we change the string array to being read-only? We can see we no longer have access to push or pop. So when I use pop here, this function does not even exist on our type we have here, because TypeScript can figure out, okay, this is an array which is in a read-only, so this will no longer show you push or pop on your object. Where this will not work, of course, is in almost all other cases. So for example, when we have a date and we have this new date here, we do not use .hour, for example, to access our property or to set our properties, but we use the setters and getters. Why is this? Well, because under the hood, the date has its own data structure to store these values. Now, because of that, we use, for example, set hours. Now, when we say here we want to have a read-only date, we can see here that I still can use, for example, set hours 1 to change the hours, even if this is a read-only. So this doesn't work like the array approach, because TypeScript doesn't know for all the different object types what kind of functions change the internal values of these objects. Now, this is the second thing we want to do: remove certain functions on read-only objects. So for example, we want to have these set hours or set minutes and so on. All these functions should not be available on our read-only type we will create. And last but not least is Object.freeze. So let me show you what this does. We have Object.freeze here, and we can pass an object to this function, and what this will do is it will make all the properties in this object unchangeable. So what does this mean? Let's say we pass in this person. What we now can do is we can say person.name equals 1, like this, for example. And we can see, of course, we now get an error because our person here is read-only. But when we change this here back to normal, like without the read-only wrapper, we can now change this and don't get a compile time error. But the interesting part is when I now call person.name and I run this code, we can see that while I set this here on line 28, it will still be Christian at line 30. Why is this? Because Object.freeze prevents us from changing anything. It will not throw an error, but it will prevent us from changing our properties. Now, when we check the type of this freeze, we can see here that this only returns a read-only, but we want it to return our better read-only. So we will have to fix this. So this is the third thing we will do. We will say, okay, the freeze should use our better read only. So let's get started with the first thing, right? So the first thing we'll do is we will create a better read-only type. So how can we do this? Well, let's just remove all this and let's create a new type, and let's call this type better read only. We pass it in our type T, and now we will use a mapped type. I did a video about map types already. You can find it in the description and in the info box. And what we will do is we will loop over the keys which are in our type we pass in. So we will use key of T like this. So we will loop over all the keys. And what we will make, of course, is all of these keys should now be read-only. And as a value, we just use the value which is from our T key like this. And this is basically how the normal read-only type in TypeScript works. So when we check here the read-only type, we can see here it does exactly what we did now. But now let's make it a deep read-only. What we will do first is we will add a second parameter here, which we can pass, and we will say this extends Boolean, and we will say this is true. We will see later why when we use Object.freeze, but by default, this deep here will always be true like this. Now, how can we make this now recursively call into our type and also make all the other properties read-only? So basically we say when this T key here extends object, so when this is an object we access, then what we can do is we say we want to call better read-only again with this T key like this. And otherwise, if this is not an object we are using, in this case, just return T key itself, because that way we don't want to go deeper into our structure. So let's now see what we have already achieved. So we can now go in there and say person and wrap this in this better read only like this. Now, when we try to make person.address.street equal to 1, for example, we can see we get an error, and when we check what the error here is, we can see that we cannot assign something to street because it is a read-only property. So we already have achieved exactly what we wanted for the first bullet point. We made a deep read-only, which now makes sure that everything in there is read-only. Now let's also use this deep in here to check if we want to do a deep read-only. We can use this here and say, okay, if deep extends true, in this case, we will do all this stuff we did here. So we will go through this. Otherwise, we will just return T key like this, because that way it will just behave like our normal read-only. Now let's jump to the second point where we want to remove certain functions on read-only objects. For that, we need to do some type magic here. So let's create first a helper function, and let's call this function never on set, and we pass it in this T. This will always be the name of our properties. For example, here it would be the name, here address, street, and so on. And what we now want to do is we want to check if this T we pass in starts with a Z and then an uppercase letter after the Z. So what we do here is we say T extends, and then we use template literals. I also did a video about them. Check the info box or the description for it. We will then say if this T here starts with Z, and then we use infer and save the remaining part of this property name in a variable here, rem for remaining. In this case, where this starts with Z and then has a remaining part, we will do certain things. The first thing we will do is we need to check if the remaining part starts with an uppercase. Why do we have to do this? Well, it could also be that we, for example, have a function in there which maybe is called setting, and this also starts with set. And we don't want to remove this. We only want to remove these functions which start with set and then an uppercase first letter, because this is like the good practice to how you should name a setter function. So what we now can do is we say, okay, if the remaining part extends, capitalize off the remaining part. Now, what does this check? Basically, we check if this remaining here is the same as when we would capitalize it. And capitalize just uppercases the first letter of the thing we pass in here, of this string. And if this is already the same, we know that this remaining has an uppercased first letter. So we say in this case, we return never, because we call this type never on set. So when we have a setter, we want to return never. Otherwise, we just return T itself. And if it, of course, does not start with set at all, we will also just return T itself. Now, let's just recapitulate what we did here. We check if this T starts with set, and then we save the remaining part in this rem variable. We then check if the rem here is a capitalized element. So if it starts with a capitalized letter, if it is, then we return never. Otherwise, we just return T itself. And now we can use this helper type in our better read only. Because what we now can do is we can check our key and pass our key to this never on set. So what we now need to do is we need to check if this T key, so if the value of this property is a function, because we only want to do this for functions. So we say as, and then we say, okay, if the T key extends a function, so if this is a function here, in this case, we will call never on set and pass our key to it. Otherwise, we just use the key itself. So this maybe looks a little bit suspicious at first and a little bit hard to read, but basically what we are doing here is we are looping over the keys and check if the value of this current key we are looping over is a function. And if it is, Then we pass it to our help function, which checks if this function key is a setter basically, and otherwise we just use the normal key. And because when we have this never on set here, this will return never when it's a set function, and this means then that it will get stripped away from our resulting type. So this set time, for example, will never be available. So this is already it, and now let's use this in our date and see if this works. So let's go back to our date here and change this from read only to better read only. And now we say date dot, and we can see here already we don't have access to all the setters, but we have access to get and so on. But when I use set here, there is no function which allows us to change certain things because all the setters were stripped away by using our approach where we remove every function which has a set prefix and is followed by an uppercase. Now, as already mentioned, this of course is no silver bullet and you have to check if this really works for you. But in certain cases, I really like this because that way what I could do is I could, for example, say I have a read-only date and I then can create this date like this. And everywhere I only want to allow this date to be a read-only, I pass a read-only date, and this will also prevent me from using the setters. Now just keep in mind, this is only for compile time safety from TypeScript. You could still call these functions in JavaScript. So for example, you could call them with the index approach where you just call date and with your brackets set time, for example. Nothing stops you. These functions are still there to use. But I think this is like a really nice safety net, at least for your type safety. Now, the last thing we want to do is we also want to make sure that when we use Object.freeze, that this will also use our better read only function. Now let's see what this freeze here does. You can pass to this freeze function an object and it will stop this object from receiving more properties, or that you can change these properties. So let me show you how this works. So when we have this person here and we call Object.freeze on person and we then use person.name like this. Now, of course, currently we cannot change it because we have this better read only in place. But let's remove this and let's see what happens when we set the person name to 1 and then we call our name again like this. When we run this code, we can see we tried to set the person name to 1, but the person name is still Christian because this freeze here prevents you from updating these properties. Now this is, as already mentioned, on JavaScript level, at runtime level. So this is already really cool, but let's see what this freeze here currently returns. So we have our result and we see here we have this read-only person. So this is already really cool from TypeScript that it returns a wrapped read-only of your type. But we of course want that this freeze returns a better read-only type. So how can we do this? Well, let's check what this object here is. This is a declared variable here, which is of type object constructor. And this object constructor contains these freeze functions and much more in there. So what we will do is we will replace the typings of this freeze from the object constructor with our own typings. So let's go back into our code for this. And what we will do is we will say declare variable object of type object constructor. But now what we will do is we will say omit and we will then remove the freeze function from it because we want to pass our own typings for the freeze function. Now it's important, these are just types. The freeze function is still there, but just not in the type definition. So what we now will do is we will create our own freeze function declaration. So we will say we will intersect with our own freeze function, which takes a t, and we have our object here, which is also taking a t, and it will return a better read only of type t like this. And now we can see here this object here, when we call freeze on it, now returns a better read only. Now this is why I added this deep generic here, which we can use to enable or disable deep read only, because this freeze here does not support deep read only. You would have to implement this yourself in JavaScript, and this is why I will now pass in here false. And this now will ensure that the type behaves exactly as the code of the Object.freeze. Because here in the result, as you can see here, we now have the address.street and we can now change the value again, because as already mentioned, Object.freeze only freezes the first level properties and not everything in there. But what we of course still have in here is we have the possibility that we have these setters no longer available. So for example, what we can do is when we have our date here, we can just remove this here and can now have our read only date, and we can then say object.freeze with the date like this. And now when we want to call set on it, this will not work. So we can freeze our properties using JavaScript, but also have the compile time safety by using our better read-only type. And of course, this is not restricted to only setters. You're basically free to do whatever you want to check for certain functions or certain properties you don't want to have in your read-only types. So I think this is a really nice tool to have much more control over your read-only types. So thank you for watching the video. I hope you learned something useful today. If you did, please leave a like and subscribe to the channel to stay up to date for the newest TypeScript stuff. And also let me know in the comments what kind of topics you'd like to have covered in future videos. See you in the next one. Bye.